So hi, I'm going to go over the antibody right here, my beautiful model. So I'm going to start with the disulfide bonds, and these are the little blue dots. They're kind of hard to see, but they're blue dots there and here on the hinge. And these are the things that hold the heavy and light chains together. And here these ones here just hold the two main heavy chain armed like chains together, and then up top they hold the light chain to the heavy chain to create that fragment antigen binding arm, the Fab arms, which I'll call them from now. So the Fab arms are made up of both the light chain, which is on top here, and the heavy chain. And of course, they're held together by those disulfide bonds. So we're going to start with the heavy chain, I guess. The heavy chains is comprised of 5 subunits of, isotopes of the immunoglobulins, and those are M, D, A, and E. And those each are constant and unique within the regions of the heavy chain. And each region adds kind of a specific biological response to the heavy chain itself. And then we have the light chains here on top in red, and they are comprised of either kappa or lambda chains, and they are made up of those chains, and their sequences vary depending on the species. So the ratio of kappa and lambda will vary depending on the species. And then we have the hinge region, which is here in red, and that is made up of cysteine and proline, and it allows for the flexibility of the Fab arms. And the Fab arms are what have to open and to adjust to allow for the binding of the antigenic epitopes. And the epitopes are, of course, kind of the antigenic determinants, and they allow for a really large variety of antigen binding. So it's kind of the reason why we have such a large amount of antibodies. So the epitopes are on the antigen, and they will bind on these antigen binding sites, which I put here in orange. And that right there is the antibodies. So thank you. I hope you enjoy my little straw and nail polish model.